example? Okay, method first. Step number 1. Change to improper fractions. That's why we did that a couple classes ago. It really was to be able to add and subtract fractions. Number 2, find the lowest common denominator. What do we call the lowest common denominator for short? You probably heard it last year. It's a really obvious acronym. LCD. Not like the monitor of your computer. That's an LCD monitor. It's lowest common denominator. Lowest common denominator. Liquid crystal display, but I don't know if that's right. I just have that in the back of my head somewhere. Google it after and let me know. Multiply the numerators. Multiply the numerators. Combine the numerators. Change to mixed fraction. Change to mixed fraction. And the last step, which is always the last step, no matter what we're doing to fractions, whether we're adding, subtracting, multiplying, dividing, solving, finding, equating fractions, simplify or reduce, whichever word you like better. So change to improper fractions, find the LCD, multiply the numerators, combine the numerators, change to mixed fraction, reduce. Okay, let's do an example. 2 1/4 plus 1 2/3. 2 1/4 plus 1 2/3. Step number 1, we're going to change to improper fractions, which is what we practiced Thursday. That's where you multiply by the denominator and add the numerator. So 2 times 4 plus 1. 3 times 1. Dead silence. 3 times 1, good. Plus 2. There's step number 1, change to improper. Step number 2, find the lowest common denominator. We're looking for the lowest number we can divide by 4 and divide by 3. What is the smallest number we can divide by 4 and divide by 3? It is 12. So that's called the LCD. You could use a bigger number, like 24, like 48. It just means you have to reduce more at the end. That's why we tend to go for the lowest one. Now in our head, so I wouldn't normally write this down, but I'm just going to write it down for the first one, is we say to ourselves, what did I multiply 4 by to get 12? So then what does that mean about the top? We also multiply by 3. Okay, so if I multiplied 4 by 3 to get 12, I have to do 9 times 3, which is? Again, if that didn't come to you right away, that's why we're doing flashcard Fridays and mental math, is to increase those skills. We do the same thing on this side. We say in our heads, how do I go from 3 to 12? What do I multiply 3 by to get 12? So what do I have to multiply 5 by? Exactly the same by 4. The stuff in the light purple I would not write. Normally I'm just doing it for you the first example so you can see. So 5 times 4 is 20. That's multiply the numerators. Combine the numerators is where we combine the denominator. So we write it out at 12 and we just put those numerators together. What's 27 plus 20? Okay. Combine the numerators, smush them together. Change to a mixed fraction. Again, this is why we practiced on Thursday. So how many times does 12 go into 47? Offer of 3. Confirmed. How many's left over? 11. Last one is we reduce. We look at that 11 over 12. Is there anything I can divide 11 and 12 by? And how do you know? Because 11 is a prime. There's your final answer. Who are my right brains, especially my strong right brains? If you guys could start getting in the habit of boxing your answers, it's a lot easier for me to find, because right brains tend to work kind of all over the page. Left brains tend to work down, right brains work all over. So if you can box the final one, it's just easier for me to find. You've only seen one example, so I want to see your thumb, and if you're here, that's okay. This is good. The first example went well. So show me really high so I can see. Just wait for everyone. Good. Is that not the cutest thing ever? Did you glue the whole thing down? That's okay. Next time you'll know. We're going to do 2 more tomorrow, so not the end of the world. Okay, so coach has shown you the play that we're going to learn, or the skill that you're going to learn, or I've played a piece of music for you, or I've shown you a new down step. Now we're going to practice together. And then you're going to practice at home. What does WS stand for? Worksheet. Sometimes we'll do worksheets when I just don't like the questions in the book. Sometimes there's too many, sometimes they're too repetitive. So worksheet means worksheet. So we talked about this a bit yesterday, but let's just do an integer refresher. We need to look at what happens when you have a times, or a plus times a plus, when you have plus times a minus, minus times a plus, minus times minus. I would love to learn a little graphy thing. What does it look like? Like a tic-tac-toe? Yeah. Okay. And then plus plus? I'm just guessing here. Minus.
Minus, like, no.
Oh.
There's a minus in the middle, and then like that. Right?
This way or this way?
That way.
Okay. Okay, I'm going to pause. I'm going to do this, and then I'm going to get you to show me after, because I'm really curious to know how this, because this is very right-brained, and I'd love to learn it. Is it dead? What happens when you multiply a positive number by a positive number? It turns out to be positive. You can write whatever you want. It's your notes. Positive times a negative? Negative times a positive? And a positive times a positive, or a negative times a negative? If you are a wordy person, here's how to say the exact same thing in words. When the signs are the same, the answer will be positive. I'm going to repeat that if you're a wordy person. If the signs are the same, the answer will be positive. You're ahead of me there. If the signs are different, answer will be negative. I'll repeat that. If the signs are different, the answer will be negative.
Does that work for division too?
Yep. So the way I remember that for the right brain people is if 2 people are the same, generally you have a good time. So it's a positive experience. If 2 people are different, really, really different, what happens? You tend to have a negative experience because you typically don't get along. So if you're the same, you tend to be positive. If you're different, you tend to be really negative. Okay, so here's our first example. So you've actually done these questions last year. We're just making the numbers a little bit harder or throwing in some of this negative stuff. The first thing you want to look at is negative. What's going to happen? It's going to turn positive. So when I write down example number 1, I'm just going to write it as a positive. Okay. And then I'm just going to make a note for when you look back. That came from the negative that's in the question. Once I've combined those, I can drop those brackets, because the brackets was just to separate those 2 negatives. Now we're on the steps that we just copied down. So step number 1 was change to improper fraction. Don't need to, right? Because we don't have a mixed fraction. Lowest common denominator. What's the smallest number we can divide by 5 and by 10? 10. So we're going to write these both over 10. Step number 3 is to multiply the numerators. So 5 times what gave us 10? 2. So 2 times 2 gives us 4. What times 10 gave us 10? So 1 times 1 is 1. Now we keep the denominator, combine the numerators. I use the word smush a lot, which is not a technical math term, but I just made it up. Smush the numerators means just put them together. 4 plus 1 is? Change to improper. Don't have to. Reduce. 1/2. Questions so far? Am I a left brain or a left writer? I am left-brained and I'm a right-handed person. I'm very left-brained. Okay, B, we got a positive, negative thing going on in the middle, so what's that going to become? If you're opposite, you have negative experience. So I'm just going to jump right ahead and write that as a negative. Step number 1, change to improper fraction. Don't need to. Step number 2, LCD. Not OCD, that's something different. Step number 3, multiply the numerators. So the first fraction, how do we go from 9 to 9? Times 1, so 1 times 1. Second fraction, how did we go from 3 to 9? Times 3, so 2 times 3? 6. Oh, thank you. Step number 3 is smush the numerators or combine the numerators or put them together. Some people might want to write it out as one step, and if your brain needs that, then that's fine. If you can jump straight to what is 1 minus 6? Minus 5 over 9. Okay, so I'm just going to put this step in brackets. If your brain needs it, great, put it. If you don't, no big deal. Change to improper. I meant change to mixed. Don't need to. Reduce. Don't need to. A thumb now after 3 examples. I'm liking this, I'm getting it, I understand. You have to put them really high because I can't see when your thumb's down here. Awesome, let's do another one. Sorry, what do I? Lots of fractions and brackets and crap going on here. All you need to look at first are the 2 signs in the middle. If they are opposite or different, it is negative. So I'm going to jump right to the negative. If I take away if I write the negative, I can take away the brackets. Step number 1. Now you're probably like, oh my God, she's already said this 4 times. Why do I keep saying the steps every time? So you know, but who needs me to say the steps every time? What kind of people? The auditories. That's why I keep saying it. If you're like, shut up, just don't listen to me. Step number 1, change to improper fraction. Go ahead and do that. Bottom times the big number, add the numerator. Three times 3 plus 2. 4 times 1 plus 3. What's going on where what? I'm just doing step number 1, which is change to improper. Step number 2, common denominator. Write down the common denominator. Just a side note, the last few examples I did it with you. This time I'm telling you what to do and then letting you do that. What kind of brains need that? That's tactile. They need to do it before they see me do it. The common denominator between 3 and 4 is 12. Okay. Multiply the numerators. So figure out what did you multiply the bottom by, multiply the top by the same number. Just a little bit ahead of me. What did we multiply 3 by to get 12? So 11 times 4. What did we multiply 4 by to get 12? Multiply 7 by 3. Now this one, if you're like, wow, my multiplication skills suck, and only you will know that because you'll know if you could do this before or not, then come see me. We can start flashcards early with you. There's also some really great apps if you've got a tablet or you've got a phone or you've got a computer that I can set you up with. If you do 10 minutes a day of multiplication facts, by the end of the semester you will know these off by heart. So if your skills suck, send me an email and I'll set you up with some extra practice. Step number 3, combine the numerator. Okay, so smush it together, combine it, 44 minus 21. Some brains need to do it off to the side vertically, if that's the way you learn to subtract. So if you need to do it that way, do it that way. Okay, if that doesn't mean anything to you, don't do it that way. So 4 minus 1 is, and 4 minus 2 is, so we should have 23 on the top. Change back to mixed. Go ahead and do that. How many times does 12 go into 23? What's left over? Reduce. Done. Turn to someone in front, behind, beside you. I want you to do D and E together. So the next 2 examples, do them together. And we'll talk in about 3 minutes. If you're still working, that's fine. I'm just going to drop my pen on the floor, and then I'm going to slowly start working through so you can check yours. Okay, do you smell bacon too? Totally smell bacon. I'm doing D. I think I'm doing D. Yes, I am. So it's only when they're right together that we change them. This, we're just going to leave them because they're apart. So if we have this together, that's where we combine them. If they're just a separate, we just leave them for now. So it's this step here we're going to worry about that negative, and all we're going to do is just combine it. So negative 25 plus 19. Minus 25 plus 19. Negative 6. Let me show you a trick on a number line that works for right brain people. So I'm going to go over here to negative 25, which is our starting number. And I want to go 19 in the positive direction, which means I'm going towards the positive numbers. So if I go 19 units towards the positive, where am I going to end up? So if I'm at negative 25 and I'm going 19 in the positive direction, I'm going to end up at minus 6. Okay, there's a number line way to do the integers. Can we reduce negative 6 on 10? Final answer is negative 3/5. Who got that? Awesome, high five to you guys. If you didn't find out what step you messed up on and fix it. E. Step 1, change to improper, so 3 times 2. 3 times 2, plus 1. 2 times 2, plus 1. LCD between 3 and 2. What do I multiply 3 by to get to 6? So 7 times 2. What do I multiply 2 by to get to 6? So 5 times 3. Keep the bottom, smush the top together, 14 plus 15. Change to mix, how many times does 6 go into 29? Leftovers? Can we reduce? Final answer. Annika.
Could you redo D?
So let me know if there's a step you don't see or you're not sure where it's coming from.
I don't get the number line.
That's just for right brains, just to add the fractions. If it doesn't mean anything to you, just completely ignore it. It's just a different way to add negatives.
If you add like negative, positive, and the negative is bigger, then the answer always negative.
So minus 29, or minus 25 plus 19. So you're going to have 6 left over. Ah, okay, got it. Go ahead and try F. F has 3 fractions. Whoo-wee. Are any of the steps